Installing a shunt trip breaker involves several key steps. Firstly, install the breaker. Mount the shunt trip breaker in the electrical panel according to the manufacturer's instructions. Secondly, connect the line side, which is the power supply. Connect the black or red wire from the power supply to the line terminal on the breaker. Thirdly, connect the load side, which is the equipment. Connect the black or red wire to the load terminal on the breaker. Fourthly, ground the breaker. Connect the green or bare copper wire to the ground terminal on the breaker. Fifthly, wire the shunt trip coil. Connect the two wires from the shunt trip coil, one black and one white, to the trip terminals on the breaker. Now let's discuss the termination of the shunt trip at the receptacle. Firstly, remove the faceplate. Remove the faceplate of the 120 volts receptacle. Secondly, connect the shunt trip wires. Connect the black wire from the shunt trip breaker to the line terminal on the receptacle. Connect the white wire from the shunt trip breaker to the neutral terminal on the receptacle. Thirdly, secure the wires. Use wire nuts to secure the connections and tuck the wires neatly into the electrical box. Fourthly, reinstall the faceplate. Replace the faceplate to complete the installation. Now let's cover the termination of the shunt trip at the breaker. Firstly, remove the cover. Remove the cover from the shunt trip breaker. Secondly, identify the shunt trip terminals. Locate the terminals labeled trip on the breaker. Thirdly, connect the shunt trip wires. Connect the two wires from the shunt trip coil, one black and one white, to the trip terminals. Fourthly, secure the wires. Use wire nuts to secure the connections and tuck the wires neatly behind the breaker. Fifthly, replace the cover. Replace the cover to complete the installation. It's crucial to remember some additional notes. Ensure that the electrical system is turned off and energized before performing any electrical work. Use appropriate wire gauges as specified in the National Electrical Code, or NEC. Follow all safety precautions and manufacturer's instructions. If you are not familiar with electrical work, it is recommended to hire a qualified electrician for proper installation. Shunt trip breakers are designed to remotely or automatically trip a circuit breaker. They are often used in commercial and industrial settings as a safety mechanism, especially in situations where a fire suppression system or emergency shutdown is required. Understanding how to properly install and terminate these breakers is essential for ensuring the safety and proper functioning of electrical systems. The installation process begins with selecting the correct shunt trip breaker for the application. Breakers are rated for specific voltage and current levels, so it's crucial to choose one that is compatible with the electrical system. The manufacturer's specifications will provide detailed information about the breaker's capabilities and limitations. Once the breaker is selected, the next step is to mount it in the electrical panel. The panel should have sufficient space and be properly grounded. Follow the manufacturer's instructions for mounting the breaker securely in the panel. Next, the line side, or power supply, needs to be connected. This involves connecting the incoming power wires to the line terminals on the breaker. Typically, the black or red wire, representing the hot conductor, is connected to one terminal, and the neutral wire, which is usually white, is connected to another terminal. It's important to ensure that the connections are tight and secure. After connecting the line side, the load side, which is the equipment or circuit being protected, needs to be connected. This involves connecting the outgoing wires to the load terminals on the breaker. Again, ensure that the connections are tight and secure. Grounding the breaker is a critical step for safety. Connect the green or bare copper wire to the ground terminal on the breaker. This provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock hazards. The shunt trip coil is the component that actually trips the breaker when activated. It typically has two wires, one black and one white. These wires need to be connected to the trip terminals on the breaker. The specific terminals may be labeled differently depending on the manufacturer, so refer to the breaker's documentation. Terminating the shunt trip at the receptacle involves connecting the shunt trip wires to the corresponding terminals on the receptacle. Firstly, remove the faceplate of the 120 volts receptacle to access the wiring terminals. Identify the line terminal, which is where the hot conductor is connected, and the neutral terminal, where the neutral conductor is connected. Connect the black wire from the shunt trip breaker to the line terminal and the white wire to the neutral terminal. Secure the connections using wire nuts, ensuring that the wires are tightly twisted together and that the wire nuts are properly tightened. Tuck the wires neatly into the electrical box, being careful not to damage the insulation. Finally, reinstall the faceplate to complete the installation. Terminating the shunt trip at the breaker involves connecting the shunt trip wires to the appropriate terminals on the breaker. Firstly, remove the cover from the shunt trip breaker to access the internal components. Locate the terminals labeled trip on the breaker. These terminals are specifically designed for connecting the shunt trip wires. Connect the two wires from the shunt trip coil, one black and one white, to the trip terminals. Secure the connections, ensuring that the wires are tightly connected to the terminals. Tuck the wires neatly behind the breaker, being careful not to obstruct any other components or wiring. Replace the cover to complete the installation. Throughout the installation process, it's essential to adhere to all safety precautions and manufacturer's instructions. Ensure that the electrical system is turned off and de-energized before performing any electrical work. This can be accomplished by turning off the main breaker or disconnecting the power supply to the circuit. Use appropriate wire gauges as specified in the National Electrical Code, or NEC. The NEC provides guidelines for wire sizes based on the current carrying capacity of the circuit. Using the correct wire gauges ensures that the wires can safely handle the current without overheating or causing a fire hazard. Follow all safety precautions, such as wearing appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Be aware of potential hazards, such as exposed wires or energized components. If you are not familiar with electrical work, it is recommended to hire a qualified electrician for proper installation. The electrical work can be dangerous, and improper installation can lead to serious injury or property damage. A qualified electrician has the knowledge, skills, and experience to safely and effectively install shunt trip breakers and other electrical equipment. In addition to the installation process, it's also important to understand the testing and maintenance requirements for shunt trip breakers. After installation, the breaker should be tested to ensure that it is functioning properly. This can be done by simulating a fault condition and verifying that the breaker trips as expected. Regular maintenance is also important to ensure the continued reliable operation of the breaker. This may include inspecting the breaker for signs of damage or wear, cleaning the breaker contacts, and testing the breaker's tripping function. Shunt trip breakers play a crucial role in protecting electrical systems and personnel. By following the proper installation, termination, and maintenance procedures, you can ensure that these breakers provide reliable and effective protection. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Shunt trip breakers are essential components in electrical safety systems, providing a means to remotely de-energize a circuit in emergency situations. Understanding their installation and termination is critical for electricians and anyone working with electrical systems. The basic principle behind a shunt trip breaker is to provide a way to disconnect power to a circuit from a remote location or automatically in response to a specific event, such as a fire alarm activation. The shunt trip mechanism is essentially a solenoid that, when energized, mechanically trips the breaker. This is different from a standard circuit breaker that trips due to overcurrent or short circuit conditions. The shunt trip coil is typically a low voltage device, often operating at 120 volts alternating current or 24 volts direct current, which allows it to be easily integrated with control systems and emergency shutdown circuits. The installation of a shunt trip breaker begins with selecting the appropriate breaker for the application. This involves considering the voltage and current requirements of the circuit being protected, as well as the specific requirements of the shunt trip mechanism. The breaker must be rated to handle the maximum current that the circuit is expected to draw, and the shunt trip coil must be compatible with the available control voltage. Once the breaker is selected, it is installed in the electrical panel in the same manner as a standard circuit breaker. The breaker is mounted on the panel's busbars, which provide the electrical connection to the power supply. The line-side conductors, which bring power into the breaker, are connected to the breaker's line-side terminals. The load side conductors, which carry power to the circuit being protected, are connected to the breaker's load side terminals. It is important to ensure that all connections are tight and secure to prevent overheating and arcing. In addition to the power connections, the shunt trip breaker also requires a control wiring connection to the shunt trip coil. This connection typically consists of two wires, one for the control voltage and one for the return. These wires are connected to the breaker's shunt trip terminals, which are usually located on the side or front of the breaker. The control wiring must be properly insulated and protected to prevent accidental shorts or grounds, which could cause the breaker to trip unexpectedly. The termination of the shunt trip wiring at the remote control device or emergency shutdown system is equally important. The control wiring must be connected to a device that can provide the necessary control voltage to energize the shunt trip coil. This device could be a manual switch, a relay, or an automated control system. The wiring must be properly sized to carry the current required by the shunt trip coil, and the connections must be secure and reliable. In many applications, the shunt trip breaker is used in conjunction with a fire alarm system. When the fire alarm is activated, a signal is sent to the shunt trip coil, which trips the breaker and disconnects power to the protected circuit. This can help to prevent the spread of fire by de-energizing electrical equipment that could contribute to the fire. In other applications, the shunt trip breaker is used as part of an emergency shutdown system. In the event of a critical process failure or other emergency, the shunt trip breaker can be tripped to quickly de-energize equipment and prevent further damage or injury. The shunt trip breaker is a versatile and important safety device that can be used in a wide variety of applications. Proper installation and termination of the shunt trip wiring are essential for ensuring that the breaker functions correctly and provides reliable protection. It is always recommended to consult with a qualified electrician when working with electrical systems and to follow all applicable codes and standards. When installing a shunt trip breaker, there are several key considerations to keep in mind. Firstly, always ensure that the power is turned off to the circuit before working on any electrical connections. This is essential for preventing electrical shock and injury. Secondly, carefully follow the manufacturer's instructions for installing and wiring the shunt trip breaker. The instructions will provide specific details about the breaker's terminals, wiring requirements, and operating characteristics. Thirdly, use the correct wire size and type for all electrical connections. The wire size must be adequate to carry the current required by the circuit, and the wire type must be suitable for the environment in which it is being used. Fourthly, make sure that all connections are tight and secure. Loose connections can cause overheating, arcing, and even fire. Fifthly, test the shunt trip breaker after installation to ensure that it is functioning correctly. This can be done by applying the control voltage to the shunt trip coil and verifying that the breaker trips as expected. In addition to these general considerations, there are also some specific requirements for installing shunt trip breakers in certain applications. For example, in healthcare facilities, shunt trip breakers are often used to protect critical life support equipment. In these applications, the shunt trip breakers must be installed in accordance with strict codes and standards to ensure that they are reliable and effective. Similarly, in industrial facilities, shunt trip breakers are often used to protect hazardous equipment and processes. In these applications, the shunt trip breakers must be installed in a way that minimizes the risk of accidental tripping and ensures that the equipment can be safely de-energized in an emergency. The proper installation and termination of shunt trip breakers are essential for ensuring the safety and reliability of electrical systems. By following the guidelines and recommendations outlined in this guide, you can help to ensure that your shunt trip breakers are installed correctly and provide the protection that they are designed to provide. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work.